Hello, today I wish to discuss about the portfolio management, the formulas that are used in portfolio management, and to help us understand more on it, I want us to solve this question, CPA November 2019 question 3B, and it says, Duncan Kipchumba has an investment capital of 1 million shillings. He wishes to invest the funds in two securities, X and Y, in the following proportions. So you have been given the proportions there. In security X, he wishes to invest 200,000, and security Y, 800,000. The return on these two securities depend on the state of economy as shown below. You have been given the state of economy, boom, normal recession, and you have been given their probabilities, their return on security X and returns on security Y. Then you have been told required A, the expected return on the portfolio, 3 marks. B, the correlation coefficient between security X and security Y, 4 marks. And C, portfolio risk, 2 marks. And D, you calculate the reduction in risk due to portfolio diversification, 2 marks. So that's a total of around 7, 8, 9, 10, 11, around 11 marks. So to start with, you have been told you calculate the expected return on the portfolio. So that's the first thing I want us to understand, how to calculate the expected return of individual security. The expected return. So you have been given security for security X and for security Y, the expected returns of them. So to start with, for the security X, the expected return, for the formula that we use, you look at you take the returns of security X, then you multiply by their probabilities. Returns of security X, you multiply by their probabilities. So in this case, in security X, you have been given their security X, their returns 18% and probability 0.4. Return security, the other one 14%, 0.50, 12% and 0.10. So they are the ones that you are going to multiply, so you get their summations. So for security X, we are saying you are going to take the 18%. So you say 18, you multiply by 0.4, then you add 14, you multiply by 0.50, then you add 12 times 0.10, so that you get the expected return of security X. So in this case, it's 18 times 0.4, you add 14 times 0.50 plus 12 times 0.10. So you are going to get it as 15.4%. So that's the expected return of security X. Then you go to security Y. For security Y, you do the same, 24% times 0.40, 22%, times 0.50, 21%, and 0.10 when you are. Then you add all of them. So 24 times 0.4, you add 22 times 0.50, then you add 21 times 0.10. So from that, you will get 24 times 0.40, you add 22 times 0.50, you add 21 times 0.10. So you are going to get it at 22.7%. 22.7%. And from that, you have been able to solve the first question. So you have already gotten your 3 marks, the expected return on the portfolio. Then from there, question B, you have been asked to compute the correlation coefficient between security X and security Y. So B, you have been asked to compute the correlation coefficient of X and Y, security X and security Y. So to be able to get the correlation coefficient, which is usually denoted by R, small r, the formula is usually the covariance of XY. You divide by standard deviation of X, you times na standard deviation of Y. So yeah, your X and Y, they are the standard deviations. So from this, you see, you are supposed, first of all, in order to get the correlation, you are supposed to compute the covariance, and you are also supposed to compute their standard deviation. So let's start with computing the standard deviations. And for standard deviation, it's denoted by that sign there, over there. So to get the standard deviation, the formula is usually square root, you open the bracket, summation, return of X. So to get standard deviation of X, return of X minus expected return of X squared, you times na probability, you times with the probability. So in this case, you are going to get this, you are going to take this 18 minus this 15.4, the expected return. This is the sign for expected return. It is the one that we are writing here. So it's going to be square root. So in this case, the first one will be 18, this 18 minus 15.4 squared, you times with the probability, the 0.40, then you add the other one, 14, the 14, you minus with the 15.4 squared, you times with 0.50, then you add the other one, 12, this 12, you minus with 15.4 squared, you times with the probability, which is 0.10. Then you find the square root of them. So to solve that, we start with the first one. So it's going to be 18 minus 15.4. 18 minus 15.4. You get the answer. Then you say squared, answer squared. Then you times with 0.40. So let's repeat again. 18 minus 15.4. You square it. Then you times with 0.40. So you're going to get 2.704. Then you add 14 minus 15.4, answer squared, you times with 0.50, get 0.98. Then you add with the other one, 12 minus 15.4, you square it, you times with 0.10. So you're going to get 1.156. Then you add all of them, the 2.704, you add with 0.98, you add with 1.156, you add all of them, so you get it's 4.84. So you get the square root. So meaning the standard deviation of X will be square root of 4.84, which is 2.2. So you have already gotten our answer here, which is 2.2. We do the same for Y. So when you do for Y, it's the same thing, square root, summation of return of Y minus return of Y squared, you times with the probability. So when you square root, you start here again. So it's going to be 24. You minus with the 22.7 that we got over there. 22.7 squared, you times with the probability, the 0.40. Then you add 22 minus 22.7 squared, you times with 0.50. You have them over there. Then 21 minus 22.7 squared, you times with 0.10. They are there, all of them. They have been showed there. So when you do that, so you are going to get, so we start the first one, 24 minus 22.7. Answer, we square it. We times with 0.40. We're going to get 0.676. Then we add 22 minus 22.7. Answer squared. Then you times 0.50. So let's repeat again. 22 minus 22.7. Answer squared times 0.50. So we get 0.245 plus 21 minus 22.7. Answer squared, you times with 0.10, which is 0.289. So we add all of them, then we square them. So 0.676 plus 0.245 plus 0.289. You add all of them, which is 1.21. Then you find the square root of it, which is, so the standard deviation of y is 1.1. We have already solved now the standard deviation, the standard deviations, the two standard deviations. Those are the formulas, the way of calculating them. So from there, now we get the covariance. We now solve the covariance when we have those our figures over there. They are just here. Let me just keep them here. So from there, now to get now the covariance of xy, the formula will be covariance xy. So it's going to be summation return of x minus return of expected return of x, return of y minus expected return of y times the probability. Yeah, so it's going to be that way. And this the one that is here, so we are going to get the ones that we are having over there, the ones that we are having over there, which are the ones that we were subtracting, the ones we were subtracting. Just wait a minute. Yeah, the ones we were subtracting over here. So the return of x at this point, it was 18. So you are going to get 18 minus 15.4. Then for y, it was 24 minus 22.7. You times with their probability. It was 0.40. Then you get the other one. Just wait a minute. Yeah. So it's here, it's back here. The question, we have it. Yeah, so we have our question here. So to get the Rx minus Rx, the expected return of x, so we are saying it's 18 minus the expected return that we got 15.4. So you are going to times the probability 0.40, and the same for y. So you are going to categorize them into 3: the boom, the normal, and the recession. You are going to look at them and in those two angles. So in this case for boom, when we multiply the covariance, we'll get 18 minus 15.4. You multiply 24 minus 22.7 times 0.40. So we get it at 566.592. Then for normal, the same. For normal also, it's going to be 14 14 minus, it was 15.4, then the other one 22 minus 22.7, then you times with 0.50. So it's going to be 14 minus 15.4, then you multiply 22 minus 22.7, then you times 0.50. So it's going to be 0.49. Then for recession, the same case, the same way as we do for the recession. So for recession also 12 minus 15.4 with 21 minus 22.7, you times with 0.10. So it's going to be 12 minus 15.4 times 21 minus 22.7, you times with 0.10, which is 0.578. Let's repeat the first one again. 18 minus 15.4, then you times with 24 minus 22.7, then you times with 0.40. So we had made a mistake. The first one is 1.352. Now we add all of them, the summation, because you are saying it's the summation. So we add 1.352 plus 0.49 plus 0.578. 1.352, you add 0.49, you add 0.578, you get 2.42. So meaning our covariance XY, it's 2.42. But what was our question? You had been asked, you calculate the correlation coefficient between security X and security Y. And we said to get the correlation coefficient of X and Y, the formula is covariance of XY. You divide by standard deviation of X times standard deviation of Y, which we have computed. So now with that, we can comfortably get our correlation, which is covariance XY, standard deviation of X, standard deviation of Y. So covariance is 2.42. You divide by standard deviation of X we had got over here, which was 2.2, times standard deviation of Y, which was 1.1. So we are able to get our covariance, our correlation. So it's 2.42. You divide with 2.2 times 1.1, and you are going to get our correlation as +1. +1. That's our covariance. That's our correlation. So we have been able to solve the second question. We have been able to get our 4 marks over there, yeah, which was to compute the correlation coefficient. Then from there, question 3, you had been asked to compute the portfolio risk. So to get, how do you compute the portfolio risk? Yeah, so to get the portfolio risk, the formula is usually this way. This is the way it's denoted. So the formula, you're going to get the square root. You get the weight of X, you square it, you multiply with standard deviation of X, you square it, plus weight of Y, you square it, times standard deviation of Y, you square it, plus 2 covariance XY times weight of X, weight of Y. And I'm sure we have almost everything over here, but we don't have the weights, yeah? So we need to compute the weights. What are the weights? Weights of, so first of all, we do it over here. Let's do it over here. The weights of X and Y. How do we get it? So to get the weights, we look at this first sentence that they had written over here. So you had been told, Duncan Kipchumba has an investment capital of 1 million. This is the total amount that he wants to invest, the 1 million. He wishes to invest the funds into securities X and Y in the following proportions. So in security X, he will invest 200,000, and 800,000 he will invest in security Y. So from that, it will give us the proportions. So from X, for X, you will say you will invest 200,000 of 1 million, and for Y, you will invest 800,000 of 1 million. So we get their proportion. So from this, it's going to be 0.2 and this 0.8, and all the time it must add up to 1. Yeah. So now we have our weights, standard deviation, we have them, weight, standard deviation, covariance, we have computed it over here. So now we can comfortably compute our portfolio risk. So we are saying it's square root weight of X, which is this 0.2, you square it, you multiply standard deviation of standard deviation of X, which was 2.2. So you say 2.2 squared plus weight of Y it's here 0.8 squared. Yeah. Then you times the standard deviation of Y, which is over here 1.1 squared plus 2 times covariance XY. Covariance XY it's over here, which is 2.42. So 2 times 2.42. You multiply weight of X 0.2 times weight of Y 0.8. So with that, we can be able to compute our portfolio risk. So it's going to be square root. Let's do this first. So it's going to be 0.2 squared times 2.2 squared. We get it as 0.1936 plus 0.8 squared times 1.1 squared. We get it at 0.7744. Then you add this other one, 2 times 2.42 times 0.2 times 0.8. You get it at 0.7744. So we compute all of them. Let's do it over here. So it's going to be square root. So when you add all of them, you can start from the first one, 0.1936 plus 0.7744 plus 0.7744. We add, we get it as 1.7424. So we get the square root, so that we are going to get our standard our portfolio risk. So it's going to be square root 1.7424, which is 1.32. And from that, we have been able to compute our portfolio risk. Our portfolio risk, we have been able to compute it, and we are able to get our 2 marks from that. So the last question you had been asked to compute the reduction in risk due to portfolio diversification. Computation, the reduction in risk due to portfolio diversification. So are you going to get the reduction? You have been asked to get the reduction in risk due to portfolio diversification. Due to portfolio diversification. So the formula of getting the reduction in risk, so it's going to be the percentage change, which will be the weighted, you compute the weighted standard deviation, of the portfolio, you minus the actual standard deviation of the portfolio, then you divide with the weighted standard deviation of the portfolio. In this case, the one that we are getting here, this is our actual. Yeah, this is our actual, the portfolio risk that we have computed, the 1.32. This is our actual portfolio risk. Yeah, so now we are going to compute our weighted portfolio risk. So to get the weighted portfolio risk, we get the weight of X, standard deviation of X, you add weight of Y, standard deviation of Y, to get the weighted. Then so that you are able to subtract it with the actual that we got over there. Weight of X, we had computed it over here. It was 0.2. Standard deviation of X, we had computed it in our first paper, which was standard deviation of X. It was 2.2. It was 2.2. Then you add weight of Y. Weight of Y, we had computed it over here. It was 0.8, which is 0.8. You times with standard deviation of Y, which is 1.1, so that you get the weighted portfolio. So to get the weighted portfolio, it's going to be 0.2 times 2.2. You add 0.8 times 1.1. So you are going to get, oh, they are the same, 1.32. That's the weighted portfolio. So now we'll go back to our formula. And from our formula, we send, from our formula, let's repeat it here. Percentage change is the weighted the weighted portfolio risk minus the actual portfolio risk. You divide by the weighted portfolio risk. We want to see the reduction risk, the one that is there. So for the weighted, we have said it's 1.32. You minus the actual. The actual, we computed it over here. The one that we've computed using this formula, it's the actual, which is 1.32 also. You divide with the weighted, which is also 1.32. So when you compute 1.32 minus 1.32, that is automatically 0. Divide 1.32. So 0 divided by any number is equals to what? 0. Yeah, you see. So the amount of risk reduction, it's 0.2. 0%, sorry, it's 0.0%, because you have been asked, you look at the reduction in risk due to the portfolio diversification. So in this case, there is no what? There is no reduction of risk. And from that, you are able to get your what? Your 11 marks comfortably. For those who are able to sit for that exam, you are able to probably get all the marks. So go and practice more. The question that you are doing was CPA November 2019, question 3B, the AFM Advanced Financial Management question that was done in that seat in November 2019, question 3B. So we can stop there for today. Have a good time. Bye.